A warm welcome to all the viewers. Friends, in this video, I am going to quickly tell you when to use structural equation modeling and when can you easily use multiple linear regression. So, structural equation modeling, which has become quite famous in the recent years, which is basically of two types. So SEM is of two types: CBSEM, that is covariance based structural equation modeling, and variance based structural equation modeling, also known as PLS SEM, that is partial least square structural equation modeling. CBSEM conducted in AMOS software, which is one of the most widely used software, and Smart PLS, which is one of the most widely used software for conducting VBSEM. Apart from this, you can also do covariance based structural equation modeling in R using the package which is known as LAVAN, right? Latent variable analysis. So LAVAN stands for latent variable analysis. Similarly, for conducting variance based structural equation modeling, you can use a package in R. There are two packages, one is Seminar and the other is CSEM. So CSEM standing for composite structural equation modeling and Seminar standing for structural equation modeling in R software. So now the point over here is when to use structural equation modeling and why we should use structural equation modeling instead of multiple linear regression or multivariate linear regression, which can be done in SPSS software. So the basic SPSS software, though you can also conduct multiple linear regression and multivariate regression in Jamovi software also, which is freely accessible, though IBM SPSS is a licensed software. So we can conduct multiple linear regression, we can do multivariate regression in Jamovi as well. In Jamovi also you can do structural equation modeling, which you actually do in AMOS. So Jamovi is good enough to do structural equation modeling, basically covariance based structural equation modeling. Now I'll give you the reasons why to use structural equation modeling and when to use structural equation modeling. First reason to use structural equation modeling is when you have a large sample size. So in case you have a large sample size, because CBSEM, which works on maximum likelihood ML estimation, assumes that your data is normal in nature. So you have to establish the normality of the data and you have to assess the data which has appropriate sample size. In case the sample size is too low, you will not get proper estimates, proper matrix, proper model fit. So in CBSEM we look in for model fit indices. So broadly I can say badness of fit and goodness of fit, right? So for badness you have RMSEA and SRMR, right? And for goodness of fit you have CFI, NFI and TLI. So these are certain metrics which you look in for model fit. So in case the sample size is less, there are problems in arriving at good model fit indices. So you cannot go ahead with the analysis because your model fit indices indicate that your model does not fit adequately to the predicted data. One reason is this. So when you have large sample size, you can easily go with covariance based structural equation modeling. In PLS-SEM, the sample size and normality assumption do not hold up to that strict extent as it happens in case of CBSEM. So PLS-SEM has some relaxations upon the assumptions of sample size and normal data. So in case you have a small sample size, you can go in for multiple linear regression if you have single dependent variable, and if you have more than one dependent variable, you can go in for multivariate regression. So the second reason is that in case you have multiple indicators, so multiple indicators which are basically the observed variables, we also call them manifest variables. So multiple indicators forming a latent variable, in that case it's better to go with structural equation modeling, because multiple linear regression where you have a single dependent variable, in that case we assume that the variables, the independent variables and the dependent variables are continuous variables, they are continuous in nature and they are reliably measured with help of the variables, right? So in case the indicators are there are multiple indicators of a latent variable, you go in with structural equation modeling, because structural equation modeling helps to separate the true variance, from measurement error, which leads to more accurate and unbiased estimates. Now, you must have seen when we work with CBSEM and PLSSEM, say this is our latent variable and these are the reflective indicators. So, we include these indicators in the model and we assess their explained and unexplained variance, and structural equation modeling helps to separate the true variance from the measurement error, right? But in multiple linear regression we cannot take these individual indicators into consideration, rather we take the composite score of the independent variable and the composite score of dependent variable. So in that case, if we are taking composite score, that means the variables for measuring or taking in the data should be highly reliable in nature. In case they are not that reliable, we go in for structural equation modeling, because that accounts for measurement error. Third reason is, if you have multiple mediators, and moderators in your model, in that case you can go in for structural equation modeling, as now your model is a complex model, right? So you have a complex model with multiple mediators, multiple moderators and maybe multiple DVs, so multiple dependent variables, right? In that case we have a complex model and we should go in for structural equation modeling, which estimates the path coefficients of independent variable to the dependent variable, or independent variable to the mediator and mediator to the dependent variable. It assesses the complete model holistically, so holistic estimation of the model is done. Holistic model estimation is possible through structural equation modeling, which is not possible in case of multiple linear regression, which assesses the effect of each independent variable individually upon the DV. In multiple linear regression, each IV, what is its influence upon the DV, it assesses it individually for each independent variable. But holistically, if we want to see the impact, we can do predictive model validity testing also, which cannot be done in multiple linear regression. So these are the three major reasons which I have given to you, that why you should be using structural equation modeling instead of simple regression analysis. Whenever you are in doubt, you can look upon these 3 points, think about them and make a judgment, the right judgment on how to analyze your data. I hope this video was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content. Till then, thanks a lot.